Problem number 1, this is a true statement. This is a true statement because of the fact that they are the same base. That means you're just going to take the exponents and add them, and that will give you 4 to the 8th power. Number 2 is going to be a false statement because, yes, you add the exponents, but you need to keep the base. That base is not supposed to be 25. It should be 5 to the 15th power. So this is a false statement because they have the wrong base written. For number 3, this is also a false statement because you are supposed to add the exponents, not multiply them. So they have the wrong exponent. It should have been 2 to the 20th power, not to the 99th power. For problem number 4, this is a false statement. This is a false statement because you should have distributed the 4 to each of those exponents, which would make it 8 to the 8th power times 8 to the 36th power, which you would then have added the exponents together to get 8 to the 44th power. Should be 8 to the 44th power, not to the 72nd power. For number 5 is a true statement because you are distributing the exponent to each power. So 4 times 3 would give you 12. You'd get 3 to the 12th power times 3 to the 18th power. And then when you add those exponents, that would come out to 3 to the 30th power. So that is a true statement. Problem number 6, this is false because remember, anytime you have a power written to the 0 power, it should equal what? 1. It should be equal to 1, so therefore it's a false statement. Number 7 is true because they're taking that power raised to the 0, and that's going to equal 1. For problem number 8 is a false statement. X to the 8th power over x to the 5th power means that you're going to take those powers and subtract them, and 8 minus 5 comes out to a positive 3, not a negative 3. Comes out to a positive 3. For problem number 9, this is a true statement because, again, 5 to the 3rd, you're going to then subtract the exponent here, which is a 1. 3 minus 1 is going to equal 2, so you get 5 to the 2nd power. That is a true statement. For problem number 10, this is also a true statement. 3 to the negative 4th power times 3 to the 1st power, because that is a 1. You would add those exponents. That would become 3 to the negative 3rd power, but remember, we don't like having negative exponents. So in order to get rid of the negative exponent, you keep the base but do the reciprocal, so it becomes 1 over 3. And then the exponent becomes positive, so to the positive 3rd power. But 3 to the 3rd power can be written as 27, so you'd get 1 over 27. It is a true statement. Any questions so far? Okay, let's go to the next page then. Problem number 11. So for problem number 11, this is a false statement. Yes, you are supposed to multiply 3 times 5. 3 times 5 will give you 15. However, with the exponents, the v to the 4th and v to the 7th, you should have added the exponents. You should have added 4 and 7, but they multiplied, so this is where it's wrong. It should have been v to the 11th power. V to the 11th power. So this is a false statement. Okay? For problem number 12, is true. It is true. 4 times 14 will give you 56. And then x to the 8th times x to the 3rd, you would add those exponents. You would add these exponents here. And it does give you x to the 11th power. So that is true. For problem number 13, is true. This is true. You would distribute that exponent of a 4 to the 7, and you would also distribute it to the exponent for x. What is the exponent for x right now? A 1. So that means that you would have r to the 7 times 4 power over x to the 1 times 4 power, which would come out to r to the 28th over x to the 4th. Okay, so it is true. For problem number 14, that is a false statement because you have to, again, distribute it not just to the top, but you have to distribute it to the bottom. Okay, so that means you should have a to the 9 times 3 power over w to the 1 times 3 power. So you should have gotten a to the 27th over w to the 3rd power. It should be w to the 3rd, not just w. So here's where they were wrong. Okay, problem number 15. Problem number 15, which of the following expressions is equivalent to 3 to the 6th power? That would be expression D. D is the one that is equivalent. If we look at expression A, I would distribute or multiply the 3 times 3. This would come out to 3 to the 9th power. Well, that's not going to work, so I'm going to cross that off. For problem B, we would add each of those exponents, and that would come off to 3 to the 9th power as well. That's not going to work. For problem C, I would distribute the 3 to the 2 and 3 to the 2. This would come out to 3 to the 6th power times 3 to the 6th power, which would then, I'd add the exponents, and that would be 3 to the 12th power. That's not going to work. So the only one that does work is 3 to the 9th times 3 to the negative 3rd. I'm going to add 9 and negative 3 together to get 3 to the 6th power, which is what I want. Okay, for problem number 16, we're going to first focus on the numerical term, which is to the 1st power. I'm going to distribute that 4 to the 1 and to the 2. So this becomes 7 to the 1 times 4 power, which is 7 to the 4th power. But 7 to the 4th power can be worked out. It can be simplified all the way to 2,401. So we get a coefficient or a numerical value of 2,401. Then for the x term, x squared now needs to be multiplied by that 4. So that means it's going to become x to the 8th power. So you get 2,401 x to the 8th power, and that should be your final answer. Okay, for problem number 17, same concept. Again, that 4 actually does have an exponent of a 1. You're going to take that exponent of a 1 and multiply it by the 3. So that becomes 4 to the 3rd power, and 4 to the 3rd power can be worked out. It becomes 64. We also need to go ahead and distribute the 3 to the 8 as well. So x to the 8th power, that 8th power is going to get multiplied by 3. And that becomes x to the 24th power. So then your final answer here is 64 x to the 24th power. Okay, let's go on to problem number 18. For problem number 18, we're first going to focus on simplifying these numerical values. 24 over 6 can be simplified. It can be simplified to 4 over 1. The a to the 8th over a to the 3rd, that's going to be subtraction because it's division. We're going to subtract the exponents. 8 minus 3 comes out to a positive a to the 5th. So since the exponent is positive, it's going to remain on top of my fraction. Then we focus on the b's. B to the 6th divided by b to the 6th means we're going to subtract the 6's. That's going to come out to being b to the 0 power, and anything to the 0 power is equal to 1. So we're going to have 1 over 1. Okay, then if I go ahead and just combine this all together, that's going to give me 4a to the 5th. If you put it over 1, that's perfectly fine. Okay, for problem number 19, 15 over 20 needs to be simplified first. 15 over 20 can be simplified. They're both divisible by 5, so we can get 3 over 4. Then we're going to focus on the x's. X to the 4th divided by x to the 4th means we're going to subtract the exponents. 4 minus 4 gives me a 0, so that 0 power becomes 1 over 1. Then we've got the y's. Y to the 9th over y to the 2nd means we're going to take 9 and subtract 2. That's going to give us y to the 7th power. So we can write it as y to the 7th over 1. Because it is a positive exponent, it stays on the top. Then we've got the z's. So we have z to the 2nd minus the 5th. 2 minus 5 comes out to a negative 3, and we don't like negative exponents, therefore it becomes a positive exponent by removing the negative and putting it on the bottom. 1 is going to go on top. Combine all of it together. On top, you're going to get 3y to the 7th. On the bottom, you're going to get 4z to the 3rd. It'll be posted on Google Classroom, anything for them if I have anything for them to do.
Okay, can you shoot me an email SSI?
Yeah, can you send me a list of all the kids that are on there so that way I can just go to the Google Drive.
Thank you.
Okay.
I appreciate it.
Yeah. Okay, number 20. Problem number 20, we've got negative 14 over negative 21. Negative 14 over negative 21 can be simplified. They're both divisible by a negative 7. So negative divided by negative becomes a positive. That's going to come down and become 2/3. We're then going to work on just the x's. X to the negative 8th over negative 6, right? X to the negative 6, that means subtraction. So we're going to take negative 8. We're going to subtract negative 6. When we subtract negative 8 minus negative 6, that becomes x to the negative 2nd power. Again, we don't like having negative exponents, so we move that to the bottom so that it becomes positive, and we put a 1 on the top. Then we just combine it all together. This becomes 2 over 3x to the 2nd. For problem number 21, negative 12 over negative 20. Again, those double negatives are going to change to a positive. They both happen to be divisible by 4 as well. So when we simplify it, it becomes 3/5. Then for the a's, we have a to the negative 3rd over a to the negative 7th. We're going to take those exponents and subtract them. That means that we're going to do negative 3 minus negative 7. Negative 3 minus negative 7 becomes a positive a to the 4th, right? It's a positive 4. Since it's a positive 4, it's going to stay on the top. So we get a to the 4th over 1. Piece it all together, and you're going to have 3a to the 4th over 5. 3a to the 4th over 5. For problem number 22, the values 4 over 4 can simplify to just 1 over 1. Your x terms, we're going to subtract negative 5 minus negative 11. Negative 5 minus negative 11 becomes a positive 6. Since it's a positive, it defaults to the top, x to the 6 over 1. Then we're going to look at the y's. That's going to be 9 minus 11. 9 minus 11 becomes a negative 2, so we get y to the negative 2 power. We don't like negatives, so we default it to the bottom, so it becomes a positive, and we put a 1 on the top. So 1 over y to the second power. Then piece it all together. On the top, we have x to the 6th. On the bottom, we have y to the second. So x to the 6th over y to the second power. Let's go to the last page, problems 23 through 29. And again, remember, the video is going to be on Google Classroom. If I'm going too fast, you can rewatch it on Google Classroom. Okay, we have 7x to the 9th, all of it to the 0 power. All of it is to the 0 power. So remember, if we distribute that 0, we're going to distribute it to each of the exponents. Right, so 7 currently is to the first power. So if I take 7 to the first power and then multiply it by 0, that's going to give me 7 to the 0 power. And what's 7 to the 0 power? Well, 1. Okay, then I'm going to take that x. We get x to the 9th power, and we're going to multiply it by 0, which is going to give me x to the 0 power, and x to the 0 power equals 1. So if I multiply 1 times 1, I just get 1. Okay, for problem number 24, 6 over 6. 6 over 6 can simplify to 1 over 1. 6 over 6 is going to simplify to a 1 over 1. X to the 5th over x to the 9th. I'm going to take the 5 and subtract the 9. That's going to give me x to the negative 4th. And x to the negative 4th will automatically default to the bottom. So we get 1 over x to the 4th. Then we've got y to the 10th over y to the 7th. That's going to be 10 minus 7, which gives me a positive 3. Because it's a positive exponent, it defaults to the top. So y to the 3rd over 1. When I piece it all together, 1 times y to the 3rd is just y to the 3rd. 1 times x to the 4th times 1 is just x to the 4th. So we get y to the 3rd over x to the 4th. And then number 25 through 29, these are rules. You need to know what rule they apply to. So if we keep the base and multiply the exponents, keeping the base and multiplying the exponents, that is the power of powers.
Good afternoon, Northrop. We have one announcement. Remember, on Monday,
All right, for problem number 26, keeping the base and adding the exponents. When you keep the base and add the exponents, that is the product of powers. That is the product of powers. Keep the base, add the exponents. Product of powers. For number 27, keeping the base and subtracting the exponents. That is called the quotient of powers. Did you have a question, Philip?
Yeah. So for 26, if I put multiplying exponents the same.
That's not the name.
But,
You have to know the name.
oh,
You have to know the name. Because you're going to have a matching where it's going to be the name, and it's going to be the definitions, and you have to match them. Okay? All right. For problem number 28, if it equals 1, then that means that it was a 0 power. A 0 power. And then for number 29, the reciprocal for the base and to a positive exponent. You're doing the reciprocal of the base to a positive exponent. That was a negative power. A negative power. Okay? Study. Test is Monday.